Welcome to Biology My Passion. I am Soumya Harikrishna. Today we will start a new chapter in physics, that is electricity. So electricity or electric current, it is actually a form of energy which we use in our day-to-day life. We cannot even think of a few minutes without electricity these days. So more than electricity, if we tell electric current, we will get an idea. What is current? Current means flow. So if we talk about wind current, means flow of air, or we tell about water current, water is flowing. So here the same way, if I say electric current, what do you understand from that? Charge is flowing, right? Electrons are flowing. Actually, charges can be positive or negative, but in electricity, which charge is flowing? Electrons are flowing. So that's why we call it as electric current. So through what these electrons are flowing? Usually through metals. Why metals? Because we learned in metals and non-metals chapter, metals have some electrons in the outermost shell, 1, 2 or 3, right? So free electrons are there so that they can move. So usually the electrons flow through the metals, and if the electron is flowing through something or electric current is flowing, then that is called a conductor. Okay, suppose you imagine this is an electric wire, this is a wire, maybe a copper wire. We know copper is a very good conductor, right? So in a copper wire, if I simply keep this copper wire like this, is energy flowing or electric current is there? No. For electrons to flow, so we learned flow of electron is current. For electrons to flow, there should be a pressure difference, electric pressure difference between the ends. Only then the electrons can flow. So that difference is called the potential difference. Usually in a circuit, a battery or a cell will give the potential difference for the electrons to flow. So these electrons, flow of electrons or the electric current and the potential difference are related. So their relationship is actually expressed by a term called a resistance. So in this chapter, beginning of this chapter, we are going to learn about three entities or three parameters in electricity which are interconnected. So first we will learn about electric current, then we will learn about potential difference which only can cause electrons to flow or electric current to flow. Then the relationship between electric current and potential difference we will learn through resistance. Okay, so let us start from the first one, that is flow of electrons or electric current. So when this is a metallic wire, now we are not talking about a potential difference, just imagine that this is a metallic wire, through that electrons are flowing, that is called a electric current or electricity. So electricity is referred to as flow of electrons or rate of flow of electric charge. Amount of charge flowing through a particular area in unit time. Maybe this part I see, this area I am seeing, how many the electrons are passing, that is the charge, right? What is the amount of charge passing per unit area, per unit time, that is called electricity. So what is charge? So charge can be represented as, just now we learned the charge we are considering for electricity is negative charge of the electrons. Charge is represented by a symbol Q, and it is measured in a unit, SI unit of course, called the coulomb. Okay, so this you have to be very careful. Usually children confuse between the symbol and SI unit. Here the symbol for representing charge is Q and the unit in which it is measured is coulomb. That is represented using a capital C. So now we have to see what is the amount of charge flowing through an area in a particular time. So when we add a parameter called time, then we use the word rate at which it is doing. So anything can happen, but if you consider the time there, then it is called a rate of doing, right? So here also rate of flow of charge we are going to calculate in case of electricity. So to calculate Q, there is actually Q means, to calculate Q, we find N into E. N means the number of electrons and E means the charge of one electron. So if I want to find out what is the charge flowing through a particular point, I want to see how many electrons are passing into the charge of each electron, right? So one electron has a charge of 1.6 into 10 to the power of 19 coulomb, because this is the unit of charge. So 1.6 into 10 to the power of 19 coulomb is the charge of one electron. So suppose 100 electrons are flowing, what happens? Then 1.6 into 10 to the power of minus 19 into 100. We have to calculate. This is how we are finding out the charge. So this is our first equation in this chapter. Q is equal to Ne. So suppose if they give the number of electrons and ask the charge, you can find out by multiplying number of electrons with the charge of one electron. Or sometimes they will give the charge and they will ask how many electrons are passing. So if you want to find N from this, how will you calculate? N is equal to Q by E. Now we will see a problem related to this concept. So calculate the number of electrons. So what are we supposed to calculate? The number of electrons. Whenever you are getting a problem, you have to first read the question thoroughly. First time you have to read. Second time when you are reading, you have to you can write or note down what is given or what is to be found out. So calculate the number of, so number of electrons, what is the symbol N? That is what we have to calculate. Constituting 1 coulomb of charge. So what is given? Q. Coulomb means the unit of charge. So given value is a Q of charge. Okay. So now we will write what are the given values. So coulomb we know Q is equal to 1 coulomb is given. And E, charge of 1 electron, we already know 1.6 into 10 to the power of minus 19 coulomb. We have to find out N. So what is the formula? We know the formula Q is equal to Ne. So from that we know N is equal to Q upon E. So this will, if you substitute, what will you get? That is 1 by 1.6 into 10 to the power of minus 19. So if I take this 10 to the power of minus 19 to the numerator, it will become plus, right? So 1 into 10 to the power of 19 upon 1.6. So if I multiply this with a 10, both numerator and denominator with a 10, I can remove this decimal point. So 10 by 16, because I am multiplying both numerator and denominator with the same value 10 into 10 to the power of 19. But I know here the numerator is a smaller value, so I am borrowing 1 10 from here, because 10 to the power of 19 means what? 19 tens are multiplied. So from those 19 tens, I am taking 1 10 to me, so it will become 100, right? 10 into 10, 100. So how many tens are left there? Only 18, because I took 1. So 10 to the power of 18 upon 60. Okay, so now we can easily calculate what is, like first we can simplify 50. This will be 8, this will be 25, this will be 4. Then you can calculate 25 by 4. Right. So we know that 6 4s are 24, 1.028205. So what is the answer? 6.25 into 10 to the power of 18. So do we have to write any unit here? Always remember, if unit is there, you have to write. It is a number. So 6.25 into 10 to the power of 18 electrons are passing when 1 coulomb of charge is flowing. So imagine, suppose 10 coulomb or 100 coulomb charge is flowing. Those many number of electrons are, this is a big number, right? So such a huge number of electrons are flowing when the current is passing. So we learned about charge and how to calculate charge. Charge is calculated by multiplying the number of electrons into charge of 1 electron. Why did we learn about charge? Because we are going to study about electric current, which is flow of charge. So the amount of charge flowing through an area per unit time is called a current. So how can we represent it? Current or electric current is represented by a symbol I. So symbol is I, and it is measured in an SI unit called the ampere. I will come back to this. Now we will see, according to our definition, how can we make a formula to find out current. So first is I is equal to, current is equal to charge flowing through a conductor per unit time. So charge by time. Now what is the symbol of charge? Charge is equal to Q. This is represented by T, time. So I is equal to Q upon T. This is our second equation we learn in chapter. So whenever you have to find out current, you can find out it using charge and time. How many charge, what is the amount of charge flowing per, what is the time given, you can find out the current. So if I add the charge unit, SI unit of charge, we know that it is coulomb, and SI unit of time is second. So if I take this S to the numerator, it will become CS minus 1. So this ampere is nothing but coulomb per second. So coulomb per second is called an ampere. Ampere is the unit to measure current. Now there are two more type of ampere we use, smaller amounts, milliampere and microampere. Milliampere means 10 to the power of minus 3, microampere means 10 to the power of minus 6. Okay, so current means represented by a symbol I. It is the rate of flow of charge. That means the current is the charge flowing through unit time. So the charge is represented by symbol Q, time by T, and if you take the value, the SI unit, it is C upon S. Then C per S is ampere. Ampere can be measured in smaller units like milliampere or microampere also. Now we have to define what is 1 ampere of current. So if you want to see, you know that this value is measured in ampere and we are getting the value here. So if I want to get value 1 here if it is 1, here also it is 1, I will definitely get here 1, right? So how can I define 1 ampere? When 1 coulomb of charge flows for 1 second, then current is 1 ampere. So if I write I is equal to Q by T, suppose if this is 1 coulomb, this is 1 second, then I will get 1 ampere, right? So this is how we define. 1 ampere of current is defined as 1 coulomb of charge flowing through 1 second, we get 1 ampere of current. We use a device called the ammeter for measuring current. Okay, ammeter for measuring current, and the ammeter is connected in series to a circuit. So we will learn about circuit now. Now we will try to understand what is a circuit. Circuit means it is a continuous and closed path of electricity. So two things, it should be continuous and it should be closed. If it is open, will the current flow? No. We will try to draw a simple circuit with the minimum components. As we move further, we learn more and more about electricity. We will keep on adding to this circuit. Okay, so basically a current to flow, a conductor should be there, we know. But I told about something called a potential difference. Only then the current will start flowing. So who will provide a potential difference? A battery. So usually for us, the battery means a structure like this with a positive and a negative terminal. But this is actually called a cell. So an individual unit is called a cell, but when many are connected, then only we call it as battery. Okay, but for normal person, we call it as battery. But physics, this one is cell, this is battery. So how will you represent cell? Cell is represented using one long line and a short line. So the long line represents positive terminal and short line represents negative terminal. So this is a cell, but sometimes we use more than one cell. So we can draw like this another one, like that. How many cells we want, we can connect. So there is no need of marking positive and negative of each one positive and one negative terminal. Okay, now we will draw the conductor, then we will connect a gadget. Here is a bulb. Okay, this bulb, it is coming through this, and just now we spoke about ammeter, which is used for measuring current. So the ammeter is kept here, okay, and from ammeter it is connected, but we need a switch, because if you don't have a switch, the circuit will keep on glowing. We cannot control, or we can switch on or off, right, the circuit. So for that, a switch will be connected, because switch is acting like a link between the battery and the bulb. So if I draw this, now the switch is off position, but if I put a dot here, switch is on, the bulb will start glowing. So you remember, if you draw this way, this is on and this is off, right? Or another simple way of drawing is like this. So this, we know this is open, but if you want to close it, it will come like this. So this is the simplest form of a circuit. But now one more thing we have to mark, that is the direction of current. We learned the flow of electrons is current. So it is flowing from the negative terminal to the positive, because electrons are present in the negative terminal, it will be flowing to the positive terminal. But when we first started learning about electricity and we started using it, we were not aware of electrons. As a result, that time it was taken the flow of positive charge and we took the direction from positive terminal to negative terminal conventionally. So now after that, when we realize that it is not protons flowing but it is electrons flowing, still we are considering the direction the same, that is from positive to negative. So whenever you are drawing a circuit, you should involve the direction from positive to negative. So this is the simplest circuit with a cell, bulb, ammeter and switch. So we understood what is charge and what is current. Current is equal to charge by time, I is equal to Q by T, measured in ampere and also measured using ammeter. Now we are going to learn about the second parameter that we have to discuss, that is potential difference. As I mentioned earlier, without potential difference, current will not flow. Okay, so potential difference, before understanding potential difference, we will understand what is electric potential and then we will go to potential difference. So electric potential means what? Some ability, right? Capability. So here we are talking about positive charge. So we imagine there is a positive charge. I am not going into the depth, okay, just what you have to understand to have that concept clear. Infinity, there is a positive charge. I am bringing that positive charge from infinity to this point, okay. So the charge is not coming on its own, I am bringing it here. So for bringing that, what is to be done? Work has to be done, right? I did some work to bring the unit positive charge from infinity to a particular point, that is still here I brought, okay. So that is called the electric potential, the amount of work done in moving a unit charge from infinity to that point. But we are going to learn about potential difference. Okay, remember first I brought till here, okay. Next what I am bringing is from infinity, I am bringing the unit positive charge till here, then later from this charge place or this point, we are bringing the charge till here. So this is the initial point, this is the final point. So here I have to do more work because first I brought till here, now I have to bring till here. So more work is done. So the difference in that work done is called the potential difference. So the potential difference is the amount of work done in bringing a unit charge from one point to the other. Again, the amount of work done in bringing a unit positive charge from one point to the other is called the potential difference. So potential difference, what is the symbol? Here we are representing as V and it's a unit, SI unit is volt. Volt also we represent as V only. Okay, so it is measured using a device called a voltmeter. It also looks like a meter but it gives the reading of voltage. So this is otherwise potential difference is otherwise called the voltage. We usually say as voltage. So here how will we write the equation? Potential difference V is equal to amount of work done in bringing. So work done is W. In bringing, what are we bringing? Where are we doing the work? On the charge, no? So to bring the charge. So V is equal to W by Q. This is the third equation we have to study. So what was the first equation? Q is equal to NE. Second equation, I is equal to Q by D. Third equation, V is equal to W by Q. Here you can see a circuit in which voltmeter is also added. Along with the whatever we learned already, now voltmeter is also added, but you can see it is not connected the way we connected ammeter. Voltmeter is connected in parallel. Now let us write the SI unit of this. V is represented as volt. What is the unit of work done? Joule. What is the unit of charge? Coulomb. So how can we write? V is equal to J upon C. So J by C, joule per coulomb, is otherwise called a volt. Okay, this volt is nothing but J by C, joule per coulomb. Now, how will I make it 1? Numerator is 1, denominator is 1. So how will you define 1 volt? 1 volt When will we get? When 1 joule of work is done in bringing 1 coulomb of charge from one point to the other, then it is called a 1 volt. Okay? 1 joule of work is done in moving 1 coulomb of charge from one point to the other is called a 1 volt. So this is all about potential difference, and we know until and unless there is no potential difference, there won't be current. So as soon as we connect or create a potential difference, current will start flowing. It is like difference in the pressure, right? So you know that if I have a hollow tube, if I am keeping some water inside, if it is kept horizontal, there will not be any flow of water in this, right? But imagine from this side I am giving more water, then it will flow to the other end. Otherwise, in your textbook there is an example, a tank is kept on top, a tank is, maybe 2 tanks are at the same level. Will the water flow from one to the other? No, because both have same level and the same amount of water. But one is kept down, from the top one, water will come down because there is a difference in the water, right, level and also amount of water, okay, whatever. So here also, when we are using a battery or a cell, we are creating a difference at both ends, positive terminal and negative terminal. The negative terminal will have more electrons or more negative charge. Why? Because there is chemical reaction going on. Inside a battery, chemical reaction goes on, which will make the current to flow through the conductor when the conductors are connected at the end. But over a period of time, the chemicals are being used up and eventually the battery will become weaker and weaker and will stop function. Then we have to replace the battery. Clear? So potential difference is created using a battery or cell in an electric circuit. So we understood current and potential difference. Now we are going to see the relationship between current and potential difference, that is by resistance. Resistance is used using a symbol R, and its SI unit is ohm. Ohm is represented by a Greek letter. This is ohm represented. This is called omega, a Greek letter. Okay. So now we will see what is resistance. Suppose we have a circuit. Okay, and it has a potential, particular potential difference X. Okay, so there is a current Y. Now if I increase the potential difference into 2X, that means then current will also become 2Y. If I again increase the potential difference, current will also increase. So if you plot that in a graph, you know graph, this is the y-axis, this is the x-axis. So if I take current here, I am taking a value 1, 2, 3, 4, 5. Here I am measuring potential difference, here V. Suppose I take 4, 8, 12, 16. Okay, so if I measure the current and potential difference, if the potential difference is 4, current is 1. In potential difference is 8, current is 2. Potential difference is 12, current is 3. Potential difference is 16, current is 4. So if you mark these points and connect them, what are we getting? A linear curve we are getting. So this is called a VI graph. V in the y-axis, I in the x-axis, and what we are getting is representing the value of R. So this VI graph shows that at any point of time, here if you see the slope of this graph, slope means what? The amount on y-axis by the amount on the x-axis. So here 4 by 1, what will I get? 4, right? Here again if I do the same exercise, 8 by 2, that is also 4. Here if I do the same activity, 12 by 3, that is also 4. 16 by 4 also 4. So we can see that it is actually whenever there is an increase in the potential difference, there is an increase in current also, it is in a proportionally. So we can say that V is proportional to I. So this is very important. Potential difference and current are directly related. Whenever there is an increase in potential difference, current will also increase. When there is a decrease in potential difference, current will also decrease. So this relationship is called the Ohm's law. So Ohm's law states that the potential difference across the ends of a conductor is directly proportional to the current flowing through it, provided the temperature remains the same, because at the same temperature only this is applicable, but temperature changes means there will be change. So Ohm's law is very important. It just shows that potential difference is directly proportional to current. So where is potential difference we are getting? At the ends of the conductor, right? So potential difference across the ends of a conductor is directly proportional to the current flowing through it, provided the temperature remains the same. So we get the relationship V is proportional to I. Suppose if you want to change the proportionality sign, we have to add a constant. So V by I, we can take it as R. So this is actually, R is a constant, that is resistance, and this is the fourth equation we are learning. V by I is equal to R, which represents Ohm's law. So from this we can again calculate V is equal to IR, or I is equal to V by R. So these two additional formula also we can make from this by cross multiplication, because out of these three, so far we have learned current, potential difference and resistance. These three, two will be given. You will have to find out the third one. So if R is asked, you can use this formula. If V is asked, you will use this formula, and I is asked, you can use this formula. So you can find out the missing value. Now from this we can understand that V and R are directly proportional, right? So when there is a high resistance, potential difference is also very high. But current and resistance are inversely proportional. That is, when there is high resistance, current will be less. When there is less resistance, current will be more. So resistance is nothing but opposition of the conductor for the flow of current. That is, suppose you imagine you are running through a track, okay, and you are running for a 100-meter race. You or any athlete, they can just start, there is no hindrance, you are all just running and you are finishing, okay. But think about hurdles. There, each time you have to cross a hurdle, right? So can you run with the same speed? No, there is a opposition, each time you have to overcome that. So this is called a resistance. So if electron is flowing, if nobody is opposing it, it will go very fast, okay. Then that is called a conductor, good conductor, which does not offer any resistance to the flow. But when the electron is passing, in between there will wait, checking is going on, right? It's not allowing. Some kind of resistance is there, kind of appreciable amount of resistance is there, then that is called a resistor. But if the resistance is little high, then it is called a poor conductor, because current is not able to move, resistance is very high, the opposition is very high, and the last case even higher resistance, not at all allowing, the electron cannot move, then that is called an insulator. So if there is no opposition, you can just flow freely, the electrons can move, that is called a conductor. So here from this what we are understanding is, when we want to change current, we have to change voltage, right? So potential difference if you increase, current will increase, potential difference we decrease, current will decrease. But when you consider a circuit, each time if I want to increase the current, I have to change the potential difference. That is not practically possible. So we need some system where without changing the voltage source, we can adjust the current in that for our activities. So for that, there is something called a rheostat. So a rheostat will change the current without changing the potential difference. So resistance can be adjusted. We know resistance has also an impact on current. They are inversely proportional. So it's a device used for changing the current without changing the potential difference in a circuit is called a rheostat. So now we will see a few symbols here which are actually used for drawing circuit diagrams. As I already told, the first one is a cell, a single cell. Second one shows a combination of 3 cells, that is called a battery. Third is the switch on or off that I have told. First one is off position, second one is on position. Then next is a connecting wire. Suppose there is a joint. This is the one shown first. Second one, it is going over it, but they are not touching each other. Okay, they are not touching each other. That is shown by a curve. Then bulb, 2 ways we can draw, but the first one is easy for us to draw in a circuit. Then a resistance is drawn with a zigzag line, and then resistance with a line, or the other way it is called a rheostat, which is used for changing the current in a circuit. And the last two are ammeter and a voltmeter. Ammeter is represented by A and voltmeter by V. Hope you understood these three concepts very well: current, potential difference and resistance. The rest of the concepts in this chapter we will continue in the next video. Thank you for watching. Till then, stay blessed.